Welcome! In this video, we will be exploring a procedure that can be used to identify the three windings of a conventional DC machine. As you will recall, conventional DC machines feature an armature winding. Additionally, the field of a DC machine may include a series winding, a shunt winding, or both. Typically, these windings will be labeled in the terminal box of the DC machine. The armature winding is identified as A1 and A2. The series field is identified as S1 and S2. The shunt field is identified as F1 and F2. However, for various reasons, these markings may become obscured or lost. The physical construction of each winding results in predictable values of resistance. Using a digital multimeter set to measure resistance, one can use this knowledge to differentiate and identify the windings quickly and accurately. It is important to note, this test is intended for a DC machine that is benched, or in other words, not in service. If the need to identify the leads of a DC machine that is in service occurs, it must be isolated using lockout-tagout procedures before the test is applied. First, recall that the series field winding is constructed using larger gauge wire. Additionally, the series field winding tends to feature few turns of wire, meaning that it is relatively short in length. The characteristics result in a low value of resistance when a resistance check is taken across the series winding leads. As you will be able to see, the initial reading is low, around 2 ohms. Also note that when the shaft of the DC machine is rotated, the reading on the multimeter only changes by a small amount. More on that later. Next, recall that the shunt field winding is constructed using smaller gauge wire. Additionally, the shunt field winding tends to feature many turns of wire, meaning that it is relatively long in length. These characteristics result in a high value of resistance when a resistance check is taken across the shunt winding leads. As you will be able to see, the initial reading is high, around 260 ohms. Also note that when the shaft of the DC machine is rotated, the reading on the multimeter only changes by a small amount. Again, more on that in a moment. Next, recall that the armature winding of a typical DC machine is constructed in such a way as to achieve low values of resistance. This is done in order to improve voltage and speed regulation. Also, these windings are connected to the external leads via the commutator, which features insulated segments. As you will be able to see, the initial reading is low, around 8 ohms. However, when the shaft of the DC machine is rotated, the reading displayed on the multimeter begins to change rapidly and in significant increments. When the shaft begins to move, the multimeter picks up the moments when the brushes move across the insulation between the segments. This is what causes the very high spikes in resistance readings. These spikes provide a clear means of differentiating the low resistance readings that are observed when taking a reading across the armature and series field. Although the resistance measurement taken on the series field while rotating the shaft of the DC machine does change, those changes are relatively insignificant when compared to the changes that occur when rotating the shaft and measuring the armature winding. If the leads of the multimeter are ever applied to the leads of 2 different windings, it will result in an open line reading. Simply remove one of the meter leads and reconnect it to one of the other leads until a resistance reading is obtained. So, now you should have a good understanding of the winding characteristics of a conventional DC machine, as well as a method in which those leads can be identified.